Hello everyone. So today we are going to study about electronic signals and mathematical tools for circuit analysis. In previous lecture we have already seen what are the electronic signals and special types of signal. Today we are going to see Laplace transformation and Laplace transformation of that standard signal which we have studied in previous section, and inverse Laplace. And for inverse Laplace there is one method, partial fraction method. So we'll see what is partial fraction method and how to find out the Laplace inverse by using partial fraction method, and then initial and final value theorem used in Laplace transformation. So first, what is Laplace transformation? So Laplace transformation converts integral and differential equation into algebraic equations. This is nothing but a phasor, but phasor is only used for sinusoidal wave. Here, Laplace is used to can applies to general signal also, not only sinusoidal, and handle non-steady state conditions also. So the definition of Laplace, any function f of t. Now we have one function f of t. So this is a time domain function, from time domain to S domain, or we can say that Laplace domain by integrating it from 0 to infinity and multiplying by e raised to minus st with respect to dt, integrating with respect to dt. So this is what the definition of Laplace transformation, that Laplace transformation of f of t. When we take Laplace of time domain, it converted into S domain, where what is this S? So S is a plane. See, this is my S plane. So S is sigma plus j omega. So this is my sigma, that is called real axis. This is my S plane. It is imaginary axis. So imaginary axis is denoted by j omega. So that is x-axis sigma and y-axis j omega. So this is the S plane. So here we are converting time domain into S domain. F of S is a Laplace of f of t. So here Laplace f of t is given by f of S. Then if we take inverse, so this f of S is again converted into f of t. So Laplace inverse, this is the notation of inverse. So Laplace inverse f of s is equals to f of t. So it is a vice versa process. Time domain is converted by taking Laplace, we can convert time domain into S domain, and by taking inverse, S domain can convert it into T domain, that is time domain. Okay. So this is the Laplace transformation. So we have to find out the Laplace transformation for this standard signal which we have previously studied: unit impulse, unit step, exponential, sine wave, cosine wave. So first, impulse function or delta function, as we have seen the definition of impulse function, that is limit epsilon tends to infinity x of t. That means this signal tends to infinity when t is equals to 0. So when t is 0, this function is infinity, and when otherwise it is 0. So this is the condition: when t is not equals to 0, it is 0, and when t is equals to 0, it is infinity. Infinity means undefined. We cannot define it. It can be 1, it can be 2, it can be 5d. When we take integration from minus infinity to infinity in delta, that is delta t into dt. So integrating with delta t with respect to minus infinity to infinity, so it will become 1. So we will use this particular condition to find out the Laplace transformation. So according to definition, here what is Laplace transformation? To integrating this f of t with respect to 0 to with the limits 0 to infinity with respect to t into e raised to minus st d of ft. Now what is my ft? Ft is my delta t. So I am using delta t into e raised to minus t dt. Now here we know that impulse function is 0 everywhere. Okay, but when t is equals to 0, we can now we can change the limit from infinity to 0. So it is when it is equals to 0, then only it is giving the value. So we are changing that infinity to 0, so it will be 0 to minus 0 to plus 0. delta t into e raised to minus dt. Now integration of e raised to t, so it will become e raised to minus t when t is equals to 0. To substitute t is equals to 0, so e raised to 0 is 1, so it will become 1. Now what is now see, in this equation this become 1, so I'm substituting here 1, integration 0 minus 0 plus delta t into 1 into dt is equals to, now it will become 1. Okay, how? So we have already seen here, we are going to use this particular condition that delta t into t is equals to 1. So here we are using that particular condition, that is it is equals to 1. So here delta t will become 1. Okay, so the Laplace transformation of delta t is nothing but 1, and for 1 is if we take the inverse of this one, it will become delta t. Now unit step signal. So we know that unit step signal is defined as u of t is equals to 1 when t is greater than equals to 0, and it is 0 when t is less than equals to 0. So this is my unit step signal. When t is greater than equals to 0, so it shows always 1, so it is unity. This signal is unity at t, when t is greater than equals to 0. So this is the definition of Laplace transformation. So my f of t is nothing but u of t. So I'm writing here you can write u of t or rho of t. So here u of t. So now u of t is 1 when t is greater than equals to 0. So here I am writing 1 into e raised to minus st dt. Now integrate this e raised to minus st with respect to dt. So it will become, by integrating this particular term, it will become minus 1 upon s into e raised to minus st 0 to infinity. Now substitute this limits. So it will become, see, first substitute upper limit minus lower limit. So it will become 1 minus 1 upon s e raised to minus st minus s, instead at t I'm going to write upper limit is infinity minus lower limit. Okay, so e raised to minus s, my lower limit is 0, so it will be 0. So here e raised to infinite, s into infinity, anything multiplied by infinity it will become e raised to infinite. Okay, so e raised to infinity minus e raised to s into 0, 0. So e raised to infinity is 0 and e raised to 0 is 1. So here 0 minus 1. Okay, and minus 1 is 1 upon s is common. Okay, so minus 1 upon s, 0 minus 1. So it will become minus minus become plus. So it will be 1 upon s. So for unit step signal, Laplace transformation is 1 upon s. Next, exponential function. So exponential function is given by it is 0 when t is less than 0, and it is e raised to minus 80 when t is greater than equals to 0. So I'm gonna write here y of t will be e raised to minus 80 into u of t. U of t is 1. Okay, so this is y of t is equals to e raised to minus 80 into u of t. Now this is my definition. So my f of t is nothing but y of t. So instead of f of t, I'm gonna write this particular equation of exponential. Okay, so here see, y of s is equals to 0 to infinity y of t into e raised to minus t dt. So what is my y of t? Y of t is my e raised to minus 80 into u of t into e raised to minus t dt. Okay, now we'll solve this equation, or we'll take integration. So here see, 0 y of s is equals to integration from 0 to infinity e raised to minus 80 e raised to minus st dt. So now see, it will become e raised to minus, now what we'll see here AT and ST. So we'll take T common. So it will become S plus A. Now I'm taking minus sign outside the bracket. So here it will become minus minus. It will become plus. So S plus A into T. Then what is U of T? We know that U of T is nothing but 1. So I'm here writing 1 into, it will become e raised to minus S plus A into T dt. Now integrate this particular with respect to T. So it will become 1. See, integration of this e raised to minus S plus AT. So it will be minus sign outside 1 divided by S plus A into e raised to minus S plus A into T with limits 0 to infinite. So now this is minus 1 upon S plus A. Again substitute upper limit minus lower limit. So by substituting here first time we will substitute here infinity. So it will become e raised to infinite minus lower limit. Now substitute lower limit is 0. So after substituting it will become e raised to 0 multiplied by anything 0, e raised to 0. So e raised to infinite is nothing but 0 and e raised to 0 is nothing but 1. So it will become minus 1 upon S plus A into 0 minus 1. Now again minus minus, so it will be plus 1 upon S plus A. So integration of, sorry, Laplace transformation of e raised to minus AT signal will be 1 upon S plus A. Similarly, you can find out for e raised to plus AT. So here it will become Laplace of this particular term. Okay, Laplace transformation of e raised to plus AT will become 1 upon S minus A. Just sign is gonna be changed. If here it is minus, it will be plus, and here if it is plus, it will be minus. So just sign gonna change. So this is the exponential function. Next, sine function. As we know that y of t is equals to sine omega t into u of t. U of t is 1. That's why we are getting u of t. Then according to definition, here f of t. So my f of t is y of t. So write down, instead of this f of t, I'm gonna write sine omega t into e raised to minus st dt. As u of t is 1, no need to write down, or we can write it down here also. So we'll use Euler's identifier for sine equation. So this is the formula: sine theta is equals to e raised to j theta minus e raised to minus j theta upon 2j. This is the formula. So we'll substitute this according to this formula. We'll find out this here theta is nothing but omega t. So here it will be 0 to infinity. Okay, sine omega t. So instead of this sine omega t, we'll use this particular identifier. So e raised to j omega t minus e raised to minus j t. Instead of theta, we'll write omega t upon 2j. So into e raised to minus into e raised to minus st dt. Okay, now take 1 upon 2j common into, and multiply this e raised to minus st with each term. So it will be 1 upon 2j, 0 to infinity e raised to j omega t into e raised to st dt minus 1 upon 2j, 0 to infinity e raised to minus j omega t into e raised to minus st dt. Now we know that exponential function, we have already find out the exponential function. See, this is my exponential function. It was my exponential function e raised to minus AT and multiplying by e raised to minus ST. So it will, after taking all this integration, and it will become 1 upon S plus A. And for e raised to plus AT, it will be 1 upon S minus A. Okay, so we'll use this particular formula for this condition. See, here it is e raised to j omega t into e raised to minus st. So it will become, using this exponential formula, it will become 1 upon s minus j omega, and this particular term will become s plus j omega. So and 1 upon 2j is common. So it is equals to 1 upon 2j into 1 upon s minus j omega minus 1 upon 2j into 1 upon s plus j omega. Now divide and multiply this particular term with s plus j omega, and next term with s minus j omega. So it will become s plus j omega minus s minus j omega, and this denominator will become s square minus s j omega plus s j omega minus j omega square. So now s, see this minus s j omega will get cancelled with plus s j omega. Here minus s and plus s get cancels, so it will become 2, and see minus minus it will become plus, so it will j omega plus j omega 2 j omega, and in here s square plus omega square. Now this 2j get cancels, so it will become omega divided by s square plus omega square. So this is the Laplace transformation of sine omega t. So sine omega t is equals to omega divided by s square plus omega square. Next function is e raised to t. So here, according to definition, f of t into e raised to minus st into dt. So here my f of t is e raised to t. So here integration from 0 to infinity e raised to t, e raised to minus st dt. Now take t common, so it will become e raised to 1 minus s into t, and integrating this, it will become 1 upon 1 minus s into e raised to 1 minus s t, and the limit is from 0 to infinity. Now substitute upper limit minus lower limit, so it will become, see, e raised to 1 minus s, upper limit is infinite, so infinity, minus e raised to 1 minus s into 0. So it will become e raised to infinite minus infinity minus e raised to 0. So sorry, it is 0, and it is e raised to 0 is 1. So here it will become 1 upon s minus 1. So this is the Laplace transformation of e raised to t. Now we'll see what is initial value theorem and final value theorem. So if the Laplace transformation of unknown function x of t is known, then it is possible to determine initial value and final value of that particular signal. So here x of t at t is equals to 0 and t is equals to infinite. So if we know the Laplace transformation, then we can find out the final value and initial value. So statement of initial value theorem is, if x of t and its first derivative is Laplace transformable, then the initial value of x of t is given by x 0 is equals to limit s tends to infinite s into x of s. So we are going to multiply by s, and we have to take the limit from, for s tends to infinite, and in final value theorem we have, see here it is s tends to infinite s, sorry, it will be s tends to 0 into s into x of s. So this is the formula for initial value and final value. Next, inverse Laplace transform. So inverse Laplace transform is used by the following notation. So it is the f of t is equals to Laplace inverse of f of s. So here in Laplace inverse of Laplace, we are converting that S domain into time domain. So we'll see one example here. F of s is given by 6 upon s minus 1 upon s minus 8 plus 4 upon s minus 3. So we'll see, this is the formulas of Laplace transformation. So here we'll use 1 upon s is unit step, that is 1. Then 1 upon s minus a is given by e raised to at. So we'll use this particular formulas. So here f of s is equals to 6 into 1 upon s minus 1 upon s minus 8 plus 4 into 1 upon s minus 3. Now use 1 upon s is unit step, that is 1. So it is into 1 minus, now here 1 upon s minus a. So it will be e raised to at. So e raised to a is my 8. So 8t plus 4 e raised to 3t. Okay. So here it will become 6 minus e raised to at plus 4 into e raised to 3t. So this is the Laplace inverse of this particular function. Next example is f of s is given by 6x divided by s square plus 25 plus 3 into s divided by s square plus 25. Now again we will see the formulas. So this is the formula. Here we'll use 6 s upon s square. Now 25, see here the formula for sine 80 is a divided by s square plus a square, and cos is given by s upon s square plus a square. So it is in the form of s upon s square plus a square. So to make this square, we're going to do this 25 become 5 square, and here also 25 5 square. Okay, so 5 square is equals to 25. So here 6s upon s square plus 5 square and 3 into s upon s square plus 5 square. So this particular term become cos 80 is 5. So here cos 5t and cos 5t. So here multiply this 6 and 3. So 6 into cos 5t plus 3 into cos 5t. So this is the f of t of this particular f of s function.